Hello, and thanks for tuning in to a previously recorded webinar. This webinar is brought to you by the University of Kentucky Department of Forestry and Natural Resources. I'm Billy Thomas, the host for the Forestry webinar series. After viewing this webinar, if you have any questions, please email us at forestry.extension@uky.edu and we will respond to your questions. Thanks again for watching this recorded webinar, and please enjoy. Hello, I'm Billy Thomas, an extension forester here at the University of Kentucky Department of Forestry and Natural Resources, and we got a great webinar tonight. We're going to be talking about tree and log grading. I have Mr. Chad Nyman with me. Chad, thank you so much for being with us. This is a really important topic. You know, trees do a lot of things for us. Sometimes we're interested in their economic value, and certainly the quality of them is really important.
Absolutely, Billy.
Yeah, so we're going to learn about the tree and log grading aspects of it. You know, on the surface, it may seem a little simple. If the tree's kind of clear, then it's probably of a higher quality. But as I've seen in your presentation, there's a lot of detail that we need to kind of consider.
Without a doubt, Billy, it's one of those things that on the surface can be really simple, and you can learn a lot, on that general level, but when you get down in the weeds, it can be pretty complicated.
Yeah. Now, folks, I'll tell you, I don't know if Chad will brag on himself or not, but he had a chance to go through the lumber grading course down in Memphis, and very few people have had a chance to go through that course, so I know it's given you a lot of skills, and I'm just so excited that you're able to kind of share some of those skills with our audience tonight. I know we've got a lot of master loggers out there, a lot of landowners that are really interested in learning more about tree and log quality, so thank you so much for giving tonight's presentation.
Absolutely. Thank you, Billy.
All right.
Thank you for that introduction. And without any more, I'll go ahead and start into the PowerPoint here. We'll get that loaded up. As Billy was mentioning, we're going to have an introduction to tree and log grading systems. And so I want to start out, put things into perspective with a few facts about Kentucky forests and our forest industry. We'll have a few basic terms throughout, some good examples. We're going to talk about a few of the more relevant hardwood grading systems in Kentucky and how they're used to establish a grade of quality and ultimately to determine a value. And so we'll start into that here. And so roughly half of our state, about 49%, is forested. We've got right around 423,000 private individuals that own 78% of Kentucky's timberland. Corporations own about 13%. The residual of that is owned by state and federal. So as you can tell, that's a pretty small percentage. The forest industry contributes about $14.5 billion to the Kentucky economy and about 66,000 direct and indirect jobs. And so as you can see here, we've got this map showing the Kentucky industries as the blue dots. They're spread pretty well throughout the state. We've got 732 facilities in 110 of our counties, and we've got about 2,776 Kentucky master loggers. They're in every county of the state, and as you can see, the darker the color green, the more loggers that are in that county. I've got this slide in here just to show the forestry subsectors and the contribution to the state of Kentucky in billions. You've got up here logging is a relatively small percentage and relatively small amount. At primary sawmilling, which is where they're making boards and railroad ties, you can see here pulp and paper. Secondary manufacturing, which is your molding, your hardwood flooring, cabinets, and your paper converters. The important message to take away from this is that the further you process the forest products that we have down the line, the more revenue that they're producing for our state. And so the further we get into the processing, the more value that we're generating for our state, plus the jobs that are coming along with that. So that's a very important message to take away from tonight. We've got here our Kentucky hardwood sawlog production from 1999 up until now in 2017. As you can see over here, we've got about 762 million board feet produced this year coming out of our forests. So a couple of pricing terms just to keep things straight for folks. Stumpage, that's the price that is paid for standing timber on a landowner's farm. delivered pricing is the price that the sawmill pays at the sawmill delivered. You've got green lumber pricing. That's lumber that has not been dried. And then you've got kiln dried lumber pricing. And that's lumber that has been dried. So grading systems, you've got the U.S. Forest Service tree grades, the U.S. Forest Service log grades, and then you've got individual mills will typically have their own variation of log grades, and those proprietary grades are going to be really reflective of the markets that they have available to them. And so they're going to be different for every mill, and it's important to keep that in mind. And so we also have the RTA, Railroad Tie Grade specifications, and the National Hardwood Lumber Association's grading rules for hardwood lumber and cypress. You can see here in the bottom left-hand corner. So stumpage pricing is one of those things that can be really variable around the state, and there's some different reasons for that. The quality of the material, the size of the material, the quantity, how many board feet you've got out there, and species all play a pretty big role in determining that stumpage pricing. And so the location of the timber has a big part to do with the availability of high-value markets, how close that timber is to those high-value markets. The cost to get the material to the market, that includes everything from a long skid on the property, steep terrain, difficulty in the harvest, any type of transportation. It's going to play a role in that. And so as you go from the forest to the sawmill to the finished product, the ability to determine the value gets stronger. And so out in the forest, it's pretty tough to determine what the actual value of that wood is. But it's important to know that tree grade is a predictor of log grade, and log grade is a prediction of lumber grade output, or if that log is going to come out as something in a construction or an industrial grade like a railroad tie or other materials. And lumber grade is a predictor of usability of the lumber, if it's going to go into hardwood flooring, if it's going to go into cabinets, or if it's going to go into something like a Steinway piano. And so I've got this little graphic here at the bottom, and it just explains that power of estimation value. Being out there in the forest, that tree grade, you've got a pretty low power of estimation. As you get to the log grade, that power is increasing. You get over to the lumber and that finished product, and you've got a pretty good idea of the estimation of that value. So quality has a really strong effect on the markets that timber enters into. As I was mentioning earlier, for many companies, there's a limit in the quality of a log that they can process economically. And a logger can and will merchandise to multiple mills, but they have to have those markets available to them within an economical proximity to where they're at harvesting. So less high quality end product for the mill, it truly means less money for the landowner. Access is one of those issues that affects that value outside of grading systems. And so main access roads into the property, they've got to be wide enough for trucks and equipment to get through. If that property is landlocked, there has to be a way to access that property through an adjoining landowner. And so that's one thing to be considering. Steep slope, that has a limit on access. Long skid, steep slope, difficult terrain, all of that makes it more expensive to remove that timber. County road bonding, I want to talk about this just really lightly because this does directly affect landowners in a loss of timber value. It does so because it decreases the number of businesses that are interested in buying that timber and the price that they're willing to pay. So estimating stumpage value is something that always comes up. And so there's a couple of different ways you can go about this. Getting an appraisal is one way. Your least biased choice is using a reputable consultant forester that will represent you. They can even help you market your timber. A reputable industry forester or timber buyer is another option for appraisal and offers for sale. Like anything, you want to get references and make sure you know who you're working with. One other way just to get a ballpark estimate is using Kentucky's delivered log prices in Kentucky Growing Gold. That is put out by the Kentucky Division of Forestry, and it usually comes out quarterly. For East Kentucky, a good average is about 40% of that delivered log price. And if you're in Central and West Kentucky, it's usually somewhere around 50 to 60% of that delivered log price. Again, this is just an estimate. Your quality, your quantity, how many board feet per acre, those things are going to play into what your actual value is. So I want to state real quickly, we're not going to go real deep into veneer and stave logs or trees. The log grades, they don't differentiate for higher value markets like veneer or stave logs, as they were developed for grade lumber. And so anyone that is selling and purchasing into these markets, it's good to have a strong understanding of some of those more stringent quality requirements. So why would you want to use a grading system? Well, there's natural variability among trees and logs. It provides you a way to assess quality, and it also provides a means to define a financial value, and you can have business transactions. So what is tree grading, and why is it important? So it's a system to evaluate the quality characteristics of your standing trees. It separates those trees into different groups, and you can then predict the quantity and the grade of lumber that's going to come out of that. As I said, there's a big price difference between high quality and lower quality trees, logs, and lumber. So with tree grading, it began in the early 1950s. It applies the same general rules as log grading does, but to standing trees, and it's designed that way so that the tree grading rolls into the log grading system, and that log grading system rolls into the lumber grading. And so lumber grade yields, as I was saying, for each tree grade, they have been determined using NHLA grading rules. With tree grading, it's important to remember to always grade the second worst face. So we're going to get into some of these details here, and I want to try to keep you all entertained but provide enough information. We're going to talk some of this terminology first. So the grading zone, that is your first 16 feet of that main stem after a 1 foot stump. The grading section, that's your best 12 feet within that grading zone. You can make it a 14 or 16 foot grading section within the grading zone if it will produce a better grade. A term here, diameter inside bark, DIB, that's your estimated diameter measurement without the bark. And so in practice, whatever diameter that you estimate, you take about 1 inch off for that bark. And so DIT is the diameter inside bark at the top of the grading section. And so these terms are going to come in handy here in a little bit as we get talking a little bit more about tree grading. So clear cutting is a lengthwise portion of a face that's free of defects and extends the entire width of that grading face. And so a face, we're talking about 1/4 of the surface of that tree. You essentially quarter that tree into 4 separate sections, and they go up into that 16-foot grading section. And so yield, that's your percentage needed for a 12, 14, or 16-foot grading section that's free of defects to be able to meet grade. And so to visualize this, you would pick out your worst face. As you can see, we've got here the side that has the most defects in it. You want to try to group as many defects into that face as you can, and then you will then determine which face is your second worst, and that is going to be the face that will determine the grade for that tree or log. So some steps in tree grading. First, you want to measure the DBH. That's your diameter at breast height, and that's 4 feet above the ground. It must be at least an 11-inch tree, and the DBH is going to determine the tree's potential tree grade. You want to divide the tree's circumference into 4 quarters, 4 faces, and as I said, that goes up 16 feet up the tree. You want to group as many of those defects as possible into one face. Use the best 12 feet of that 16-foot face. And as we said, you can use a 14 or 16 foot if you believe you'll get a better grade. You want to make sure that you're noting what the diameter at the top of that grading section is going to be inside the bark. You want to estimate sweep, crook, and interior coal, and we'll discuss those a little bit more here in a second, what exactly those are. You want to use hardwood tree grade rules and assign a grade for the face. All faces must be graded, and the second worst will become the tree's grade. So here, real simply, we've got the clear cuttings that we need to yield for each log length by tree grade 1 up here on the top. For a 12-foot log, you would need 10-foot clear, a 14-foot log, 11-foot 7 inches, 16-foot log, 13-foot 3 inches, and you can see that those yields will go down for tree grade 2 and tree grade 3. And so, real quickly, what is included in the board foot volume of a tree is everything above that 1 foot stump up to a 9-inch top or your stopping point that contains at least an 8-foot section in length that meets both the grade, the soundness, and size requirements. And so any sections that are less than 8 foot and don't meet any grade, sound, or size requirements are considered board foot coal. And so a coal deduction is the percentage of total board foot of that grading section lost due to crook, sweep, and rot. Okay, so sweep and crook. So you want to estimate the length, the small end diameter inside bark, and the sweep or crook departure from the affected section. So that departure is how far that it will depart from the main bole of the log or tree. And so if the length is 6 foot or less, you can treat it as crook. You can use sweep and crook equations or tables to determine the amount deducted from the log or tree. And so here on the top is an example of sweep. You've got an equation here to be able to figure out your percentage of sweep deduction. You've got crook here. You can see the end of the log is crooking. And you've got your percent deduction equation down here to determine what percentage board foot you will deduct for that. So what is a stopper? So that's essentially where you're going to stop measuring to in the height of that tree. And so it's an occurrence in the tree that cannot be productively sawn through, and that limits the length of that potential log section. And so a couple of different types of stoppers. You've got double pith, where a tree will fork. And so a fork, at least a third of the diameter of the main bowl at that point of occurrence, and it's 45 degrees or less in angle from that main bowl. Getting a fork in the tree is an immediate stopper. So you can have a cluster of branches, stubs, or bumps, and if those collars are 2 inches or greater and they're within 1 foot of each other, you add those collar measures together, and the sum of those, if the sum of that is half or more of that diameter of that tree, then you would stop at that cluster of branches. And I've got a graphic that will explain this a lot better here in a minute. I know it's a tough thing to take in. And if the log surface is a grade 4, then the sum only has to be a third of that diameter to stop that log. And so any sudden dramatic change in the bowl diameter could be a stopper. If you have sweep or crook that exceeds 50%, any rot that affects 50% or more of the stem volume at any point, and any embedded metal, any fence wire, nails, anything that isn't aluminum would be a stopper. And so here we've got a pretty good picture showing greater than 50% sweep breaking that plane. And so that tree right there, we've got another picture here. You can see the crook on this tree. And that exceeds 50%. A lot of these things are easier to see with a picture than to try to describe to you. And so when you get rot that exceeds 50% at a point of occurrence, you can see some rot up in the top of this tree. We'll have a lot of pictures to demonstrate some of these different defects and how they affect grading. We want to try to keep it pretty general. I want to give you all some visuals to see different defects. Here we've got a big gall. It's 14 inches on the side of this 28-inch tree. Here you can see there's several galls going up the side of this tree. And so here we got a demonstration of this fork, and it shows you where the pith is actually going to in this tree. And so pith is that structural center of the log. It's the juvenile wood, the original stem. And so it behaves differently than the rest of the wood. And so it's not a desirable part of the wood to have into anything that you're going to be producing for lumber or any kind of industrial. And so that is why stuff like this up here is avoided, and you would end up cutting somewhere down lower in here to avoid a lot of that pith. And as you can see here, that is where that pith is intersecting all the way down into here. And so you've got several branch bumps going up and down the tree here in this picture. This cherry tree here has several branch bumps going up. And so we've got a sign put into the side of this tree here. Is there any metal in that tree? If so, then it's a stopper. And here's a good picture to visualize that whirl of branches that I was talking about. And so if you see something like this up into a tree, yes, we're getting a little bit smaller on the diameter, so we're getting close to a stopping point anyways. But you can see this whirl of branches. And so they're all within a foot of each other, and those measurements of that collar right there added together, they're going to total to at least half of that diameter up there inside the bark, and so that is going to be the stopping point. And knowing where to stop when measuring a tree and the height is a tough thing for folks to grasp at first, and with focusing your eyes and a lot of practice and estimation, you can get better at it, but knowing where to stop is a challenge for a lot of folks. So limb stoppers on grades 1 through 3. Here you've got an 18-inch diameter tree just below those limbs. You've got 3 limbs that are 3 inches at the collar. If you add all of those together, you're going to have a sum of 9 inches. And so that's half of that 18-inch tree, and that's going to be your stopping point where you're going to stop measuring your merchantable area. And so for a grade 4 tree, it only has to be a third of that diameter up there. And so you've got a 12-inch diameter below this 4-inch limb. And so as this exceeds the 1/3, that is going to be the stopping point. And so what determines a fork and what determines a branch? And so, as we were saying, anything that is less than 45 degrees is a fork. If it's anything more than 45 degrees, it's considered a branch, and it's only a stopper if the diameter is half the bowl diameter for a grade 1 through 3, and 1/3 if it's a grade 4. So a few things to look at. We've got some butt swell here on this tree. This is something that is not considered a defect. And so it's important to know what you're looking at as we go through. I'm going to show you a lot of pictures of things that are defects. And so you get very commonly butt scars on trees, and those can be from fire damage. Those can be from any kind of equipment damage from past harvest or equipment usage on that property. It's really common to see these along old skid roads, as you know, they'll use them for bumper trees. And so butt scars are very common. Here you can see a fresh one. So you've got all kinds of insect damage, different borers. It's tough to see this picture here. We'll have a few more. Here you can see a hardwood borer, and you can see the stain going down the tree. Here's a close-up of that, and you can see where it's weeping, and you can see the entrance holes. And those do cause defects with time. Any holes or seams. Seams are a big one. You'll get frost cracking that'll go up trees. It can be straight, it can be spiral, it can twist around the tree, it can be really thin, it can be wide and open. Any cracks and seams can be put on the edge of a grading face if it's vertical and goes straight up the tree, as you can see in this example. Lightning is common. Here, this is a pretty good example of what lightning damage looks like in trees. Here we've got an old epicormic branch right here, a bud right there, and these can be difficult to see to the untrained eye. And it takes a lot of experience to be able to spot some of these. And so here we've got an old suppressed bud cluster. On the surface, to the untrained eye, you know, someone may not even notice this as being different from the regular bark pattern going on. Here we can see at 1.5 inches below into that wood horizon. As we go through these different horizons, you'll get to see what that bud cluster in that previous picture look like as you go through these different horizons. So we were on the surface, you saw that initial picture. Here we are at 1.5 inches in, and you can just barely see a burl there in this section here. It's really light. You go down 2 inches, and you can see this pin knot starting to show itself. You go down to 2.5 inches, and you've got a very visible knot right here. And so that goes against a lot of intuition. You would expect this to be up there on the surface. And so a lot of folks, you know, getting to see that as it goes through these different horizons, where that defect is going to show up, and how deep into the wood it's going to go, and how much wood that is being lost to that defect, that all affects the value, the usability of that wood. And so here we have another small branch knot cluster here. Here at just a little over 1/2 inch in, we can see this defect showing up. We go in a little over 1 inch, and you can see the cluster. And so we've discussed some of these different surface abnormalities real briefly. We talked about bumps and distortions, dormant buds, and those epicormic branches, holes. You've got a little key over here that'll give you some explanation, little definitions, talking about some of those defects. You've got some of that terminology we discussed over here. talking about your diameter inside bark at the top of the grading section, clear cuttings, the sum of your clear cuttings, total cold deductions, which is your sweep, your crook, your rot. And so if you wanted to, you could use a tree grading key like this. You would start out here at the top, and you would have your DBH if it is greater than 15.6 inches. If you've got basswood or ash, it can be 14.6 inches. And you've got a yes or no column over here, and you essentially will go down and answer yes or no to the corresponding questions. If you were to answer yes, you would then go down to number 4, and you would see if that diameter inside the bark at the top of that grading section is greater than 19.6 inches. You would answer yes or no, and you would correspond to the number by your answer. And so we can roll on into log grading. And so sawmill operators, they learned a long time ago that small, knotty logs less valuable than large, clear ones. Hardwood log grading systems have been around since the early 1900s to help buyers and sellers when logs are being appraised, bought, and sold. The U.S. Forest Service Forest Products Laboratory published log grades in 1949. In 1952, these log grades became the official hardwood log grades for use by the Forest Service. Lumber grade yields for each log grade have been determined. And so we've got here a log grading spec card. And so you've got here your different specs. You've got a log grade 1, log grade 2, log grade 3. You've got your grade factors, your position in the tree. If it's a butt log, an upper log, there's different requirements for log grade 1, log grade 2, and log grade 3. You've got your minimum diameter in inches, your minimum length in feet, the number of clear cuttings, or I should say the size of clear cuttings, and the number of clear cuttings that are required to meet those requirements for log grade 1, log grade 2, and log grade 3, your maximum sweep and crook allowance, and your maximum coal and sweep allowance. So log grade expected lumber yields, if you've got a grade 1 log, it's 60% or more of the lumber that is yielded from that log should be 1 common, select, or FAS, which used to stand for first and seconds. FAS is the highest grade of lumber. Selects is essentially a FAS board that is not as wide. It has slightly reduced size limitations of FAS, but it's still a relatively clear board. And then you have 1 common. And so for grade 2 log, you should be yielding between 40 and 60% 1 common or better lumber. And for grade 3, you should be yielding between 20 and 40% 1 common or better lumber. And so here we've got some NHLA lumber grade prices for green lumber. This is lumber that has not been dried. And the reason I've got these prices here from the Hardwood Market Report, and the reason we've got these up here is just to show how variable or how different the prices are from FAS, which is the highest grade, to 1 common, down to 2 common. So for red oak, you know, you're getting around $1,135 a 1,000 board foot. You get down into the 1 common, you've got here about $830 a 1,000. You get down into 2 common, that's only $540 a 1,000 board feet. And it's similar pricing like this for yellow poplar and hard maple and any of our hardwood species. So what determines lumber quality? The National Hardwood Lumber Association was established in 1898 to provide grading rules for lumber. Each grade of lumber is determined by the size and the number of clear wood cuttings that a board will yield. Clear wood cuttings, those are sections that are free of knots, bird pecks, rot, decay, pith, which is that structural center of that log, that juvenile wood, any shake, any wane, which is your bark or lack of wood, and splits. Here I've got a table just demonstrating the NHLA grading requirements. You've got FAS, you've got your one face, which is FAS on one side, and then you've got your select, which is essentially a smaller FAS instead of, so we've got your minimum size board requirement for each of these grades going down this column here. You've got your minimum size cutting, your basic yield, and so here you can see the minimum size board for FAS, it must be at least 6 inches wide by 8 foot long. Well, if you get down into selects, you've got a board that's as nice as a FAS board, but it's only 4 inches wide and 6 foot long, when you could put that into here if it meets those minimum size cutting requirements, and you'll get the clear yield. And so when you get into one common and below, those size requirements for that board and the cuttings go down, and they are not as strict as you have a lower yield that will be required for those grades. So every property in the state is going to have trees that are end up in industrial uses like railroad ties. They're going to have regular saw timber, lumber, logs, and you're going to have maybe a small portion of veneer or stave logs or something that will go into a higher market. And so using management, you can try to increase the percentage of your trees and your timber being in those higher value markets. And just to kind of drive this home, we've got here the statewide railway tie log averages. So for 1,000 board foot, you get right around $375 a 1,000 board foot for oak railway ties. And so that's red or white oak. You see here, you've got white oak lumber price here. You're right around, $1,080 for 1,000 board foot. So you go from having a lower value industrial product, you get into some higher quality products in lumber, and your value is increasing. Oh, go back one. And so let's say you've got a little bit higher quality white oak, maybe, or a higher percentage, and you've got some stave logs. You can see that these stave logs have a higher value. They're averaging somewhere around $1,142 a 1,000 board foot. And so what all of that there was put in place to do is just to demonstrate that those markets are going to allow for a higher value price and more opportunity. And so with a bit of management and planning, you can increase that yield of quality material from a forest or woodlot. Higher quality timber has a potential to enter better markets. The skill sets and training that we talked about today, they take years of experience to develop. So don't be afraid to seek information from quality sources. Remember, there are a lot of trained professionals that can help you consult and represent you in managing your woodlands. So any questions or comments? I've got my contact information here on the left. We've got the forestry website. We have a Wood e-News Facebook page. We try to talk about relevant wood and forestry related topics. Some additional resources that I think are incredibly important and very helpful: the Kentucky Division of Forestry and the Kentucky Association of Consulting Foresters. We've got their contact information for you here as well.
Thank you for watching this previously recorded webinar. Should you have any questions about the webinar you just viewed, please email forestry.extension@uky.edu. And for more information about forestry and wildlife in Kentucky, please visit us online at www.ukforestry.org. Thanks so much.